Dear friends, welcome to the next problem of gears, that is problem 7. The data is like this. The number of teeth on the gear and the pinion of two spur gears in mesh are 30 and 18 respectively. Both the gears have a module of 6 mm and a pressure angle of 20 degree. If the pinion rotates at 400 rpm, what will be the sliding velocity at the moment the tip of the tooth of pinion has contact with the gear flank? Take addendum equal to 1 module. Also find the maximum velocity of sliding. Friends, let us note down the given information. Here, two spur gears are in mesh. The right hand side is pinion, and assuming that it is a driver, it rotates in clockwise direction, and left hand side it is a gear which will rotate in opposite to the pinion. Here we have shown the position of a pair of teeth at the starting of engagement, it is point C, and end of engagement, it is point D. So the path CPD is path of contact, where C to P is path of approach and P to D is path of recess. Here other information is like this. The number of teeth of the gear capital T is 30. Number of teeth of pinion small t is 18. Module of two gears M is equal to 6 mm. Pressure angle of them is 20 degree. The speed of the pinion NP is equal to 400 rpm. Addendum is given equal to 1 time module. We have to find out the sliding velocity at the point at the moment the tip of the tooth of pinion has contact with the gear flank, and we have to also find out the sliding velocity when it is maximum. Now we know that the sliding velocity is given by SV is equal to angular velocity of pinion plus angular velocity of gear into the distance between the pitch point and point of contact. Let us say that distance is equal to x. So here, assuming pinion as a driver, as I told, the engagement of the pair of the teeth starts at point C, as we have shown in the diagram here, and ends at point D. It ends here. So as shown in figure, at the moment the tip of the tooth of pinion has contact with the gear flank, the distance between the pitch point and point of contact x will be PD, and that is equal to path of recess. It can be shown here. This is the position where the tip of the pinion teeth is in contact with the flank of the gear. So this is the end of engagement point. So the distance will be PD between pitch point and point of contact, and that is nothing but the path of recess. So we can write that sliding velocity is equal to omega p plus omega g into path of recess. Now, for pinion, we know that module is equal to ratio of pitch circle diameter to number of teeth. So diameter is equal to module into number of teeth, that is equal to 6 into 18 gives 108 millimeter. So the pitch circle radius of pinion is equal to half of the diameter, and that is 54 millimeter. And the addendum radius of pinion is given by pitch circle radius plus addendum, and that is 54 plus 6 is equal to 60 mm. Similarly, we can write for gear that module is equal to pitch circle diameter divided by number of teeth. So the pitch circle diameter of gear capital D is equal to M into number of teeth of gear, that is 6 into 30 gives 180 millimeter. So the pitch circle radius of gear is half of the pitch circle diameter, and that is equal to 90 millimeter. And addendum radius RA is equal to pitch circle radius plus addendum, that gives 96 millimeter. So again we know that the speed ratio of gears, that is Ng upon Np, that is speed of gear divided by speed of pinion, is inversely proportional to pitch circle diameters, that is diameter of pinion divided by diameter of gear. That gives us speed of gear is equal to Np into D upon capital D. Substituting the values, we found that the RPM of gear Ng is equal to 240 RPM. Hence, angular velocity of pinion omega p is equal to 2 pi np upon 60. Substituting the values and calculating, we found that angular speed of pinion omega p is equal to 41.88 radian per second. And similarly, the angular velocity of gear omega g is equal to 2 pi ng upon 60. On substitution of values, we found angular speed of gear omega g is equal to 25.13 radian per second. Now, path of his recess is given by POR is equal to under root of R square minus R cos phi whole square minus R sin phi. So, path of recess is equal to, on substitution of values of RA, R and phi and calculation, we found path of recess is equal to 13.54 millimeter. So, using relation 1, we can write the sliding velocity at a point when the tip of the tooth of pinion is in contact with the flank of the gear tooth, that is equal to omega p plus omega g into path of recess. Substituting the values of omega p 41.88, omega g 25.13 and path of recess equal to 13.54, we found sliding velocity is equal to 907.86 millimeter per second. Now, the sliding velocity will be maximum when the distance between the pitch point and point of contact is maximum. As the pinion is a driver, the maximum distance will be path of approach. And path of approach is given by POA is equal to under root of capital R square minus R cos phi whole square minus R sin phi. and hence substituting the values of parameters, and on calculation we found path of approach is equal to 14.64 millimeter. So maximum sliding velocity is equal to omega p plus omega g into path of approach. On substituting the values, omega p is equal to 41.88, omega g 25.13, and path of approach is 14.64, and calculation we found maximum sliding velocity is equal to 981 millimeter per second. So we can conclude that the sliding velocity at the moment the tip of the tooth of pinion has contact with the gear flank is 907.86 millimeter per second, and the maximum sliding velocity is 981 millimeter per second. Thank you very much, friends. Again, I reminding you that if you have any problem, you can write me. You can write in comment also. Thank you.